Hey guys, today we are going to review all of the radical information that we've used. So simplifying radicals, multiplying, adding, subtracting, and rationalizing the denominator. Today we're just reviewing everything that we know about radicals. So the first thing that we look for is always to simplify. So we're going to break this down. 288 is an even number. So when I divide it by 2, I get 144, then 2, and 72, 2, and 36, 2, 18, 2, 9, 3, and 3. The other thing that I need to do is I need to write out my 3a's. 1, 2, 3. Now, when I look at this, I look and I see how many do I need to group in order to break it out of jail. When there's not a number, then we know that that's a 2, so I'm going to circle groups of 2. Everything I circle gets to come out. Everything I don't circle has to stay inside the radical. So I will have 2 times 2 times 3. That's my groups that I circled. And I have an A. And then inside the square root, I have a 2 and I have an A. We have to finish up this simplification. 2 times 2 is 4 times 3 is 12. A square roots of 2a. That's our answer. Let's look at number 2. For number 2, we are multiplying. So when we multiply, we're going to multiply our outside numbers, our -3 and our -3. -3 times -3 is 9. And then we multiply our inside numbers, our 2 and our 6. So we're going to have the square root of 12. The last thing that we need to do is we need to simplify 12. We have to see if we can take anything out. So 12 is an even number. So I have 2 and 6, 2 and 3. Remember that when there's not a number in front of my radical, it's a 2. So I'm going to circle groups of 2. So what that means is that I will have this 9 times what I circled, 2, square roots of whatever's left over, 3. The last thing to do is multiply 9 times 2. 9 times 2 is 18, square roots of 3, and that's my answer. Now, let's look at some division. When we divide, we can't have a radical in my denominator. So to get rid of that radical, I'm going to multiply. How many 5s do I need to break it out? Well, there's not a number there, so that means it's a 2. I have 1, so I have to multiply by another. What I do to the bottom, I have to do to the top. So on my bottom, my denominator, actually, let's start with my numerator. I have 20 times 5, so that becomes the square root of 100. Remember, we multiply the inside and we multiply the outside. Over 5 times 5 is the square root of 25. Now, I can take the square root of both of those. The square root of 100 is 10. If we couldn't take an even, then we would simplify that. You know how to do that. And the square root of 25 is 5. Now, 10 can be divided by 5. So that means that our answer is 2. Let's look at number 4. Here we're adding and subtracting radicals. The first thing that I look to see is if all of my radicals are the same. Since they are not, I'm going to simplify them first. So 54 is an even number, so I'm going to divide by 2, and I get 27. 27, I know I can divide by 3, then I get 9, and 9 is 3 and 3. 27, I know I can divide by 3, and I get 9, and 3 and 3. And 6 is a 2 and 3. Now the next thing we do is we look to see how many do I need to break it out of jail. Since there's not a number there, it's technically a 2, so I'm going to circle groups of 2. 6 doesn't have anything. So now let's rewrite this. I have this 3, and it's going to be multiplied by this group of 3. And then I will have the square root of 2 times 3 is 6, minus this 2 times this 3, and it will be the square root of 3, what I have left, minus, there's nothing to pull out of the square root of 6. Now let's rewrite this because I have a couple things that I need to multiply. So 3 times 3 is 9, square root of 6, minus 2 times 3 is 6, square root of 3, minus the square root of 6. Now I can only add and subtract terms that are exactly the same. So my square root of 6 and my square root of 6 are exactly the same. There's technically a 1 there. So 9 minus 1 is 8, square root of 6. And then this minus 6 square root of 3 just stays there. This week, all we're doing is reviewing radicals. Let me know if you need any help. Hope you have a great day.